Can you hear us? Probably you're on mute. Can you just unmute it? Dr. Krishnan, can you hear us? Probably he's on mute. Can you unmute Dr. Krishnan? And then no, we are not unmute. Probably from his side. Okay. Oh, again went back.
Can I start? Okay. Good afternoon, everyone. Today in this, I'm sorry I could not attend the very important national seminar in person. Today I'll be talking about changing monsoon precipitation extremes and what are the lessons that we have learned and the way forward.
Can you go
So
on
as
slides or
the
more? Dr. Krishnan, can you
climate
go on slide or?
continues to warm, we have crossed more than 1.44 degrees in 2023.
No, you're not
compared
able
to
to see your slides. Dr.
1857.
Krishnan, can you
And month by month, this warming is increasing.
can you make it full slide, Dr. Krishnan?
And we also know that this rate of the rise of global mean temperature is mainly caused by human activities due to the increasing
Krishnan, we are
greenhouse
not able to
gases, which have
see
warmed
the
the
slides.
planet.
Move
And in the future, as the warming continues, it is projected that even the conservative estimates, this is the low emission scenario, where only in the low emission scenarios we can be below the 2-degree warming.
Dr.
The
Krishnan, can you hear
SSP245
us?
is a kind of the middle of the road pathway where we are going to cross 2.7 degree
Dr. Krishnan, can you hear us?
temperature change by end of this century, and the high emission scenarios,
So he needs to change.
the temperature rise is even going to
The slides are not moving.
So this is a big concern. The rate of warming that we are seeing, it's going to be a very big concern. It is affecting all the components of the Earth system, and so this is, and in fact, the pattern of warming is not uniform. Mostly the polar regions and the high latitudes are warming at a much
Dr.
faster
Krishnan,
rate
the slides are not
tropics.
moving.
And also, if you see this is the observed one degree change, and this is what is simulated by the models, the CMIP6 models. And this is the kind of warming that you will get at 1.5 degree global warming level, at 2 degree global warming level, 4 degree global warming level. What you also find that is in the higher latitudes and the polar regions, the precipitation is also going to increase. And also many areas in the monsoon regions, the African region, Asian region, as the warming continues, precipitation is going to increase. But many subtropical areas, dry areas are going to get drier. So these subtropics will become dry, and the wet is going to become wet and the dry is going to become dry. This is the kind of. So one of the consequences of this temperature increase is what is known as the water vapor feedback, because with every 1 degree warming, the water vapor in the atmosphere increases by 6 to 10%. And the direct consequence of the globe, this water vapor increase is the increase in the frequency of heavy precipitation events. So they are also projected to increase at the same rate, something like 7% per degree warming. And these are the projected temperature extremes and heavy precipitation extremes over land. With warming climate, both the temperature extremes, intensity and the frequency are going to increase, and the heavy precipitation event over land will increase also at around 7%. So with a 2-degree warming climate, we will be having something like a 14% wetter climate. Heavy precipitation events will become 14% more wetter. But what does it mean for the Indian monsoon? So that is an important point, because this is all just global statistics. When we talk about the Indian monsoon, we look at it as a very large scale monsoon circulation. It is driven by this setting of this major heating over the Tibetan plateau, and during the pre-monsoon months, and the land-sea contrast initially sets up the uh, thermal contrast, and oh, okay. Oh, I heard these slides are not moved.
Can you come on PowerPoint mode? You need to come on PowerPoint mode.
Are the slides moving now?
No. Come to PowerPoint mode and then.
So, so one of the consequences of this uh, global warming is the increase in the water vapor by about 6 to 10%. And the heavy precipitation events are also projected to increase at the same rate, about 7% per degree warming. And which means at a 2-degree warming level, we will be getting almost a 14% increase in the heavy precipitation events. So the question is, what happens to uh, uh, the monsoon? What does it mean for the Indian monsoon? The Indian monsoon is actually it involves multiple scales interacting among each other. We have a very large scale monsoon, and during the summer monsoon time, we have many depressions forming in the Bay of Bengal, and they move westward, and they bring a lot of rain over central India, even in peninsular India. Recently, Vizag got a lot of rainfall, I know. We have seen that very heavy rainfall. And there are also other systems like the mid-tropospheric cyclones and so on. So the question is, how is global warming going to influence them? That is one of the biggest concerns. In my talk, I will just give an example of a few monsoon precipitation extremes that we have seen in recent times. What are their causes, the teleconnections, feedbacks, and climate change signal. And I'll just begin with the 2013, June 2013 Uttarakhand event. It was a very heavy rainfall and floods over Northwest Himalayas. And the other one was the Leh 2010 flash floods. And this was a kind of a mesoscale convective systems over the high terrain. I will also discuss about the heavy rainfall over Gujarat and Western India, where several monsoon rainstorms form and how they have been changing. And I will also briefly touch upon July, August 2022 and 2010 widespread heavy rainfall and devastating floods in the upper Indus Basin of Pakistan. Hello. आवाज हाँ नहीं नहीं हेलो
Dr. Krishnan, can you hear us?
Technician. Technician.
Ramesh Garu.
I understand that you are not hearing my.
Your voice is clear. We're not able to move your slides. Can you go back to PowerPoint mode and then start your presentation? Ah,
Hello?
Dr. Krishnan? No.
Hello? Hello?
Krishnan?
Hello? Hello? I get so many. Are you able to hear me? Are you able to hear me? Ah, oh, they were moving here. Oh, okay. Yeah, yeah. Oh, oh. Yeah, yeah.
Share the entire screen.
Okay.
Entire screen. Yes, sir.
Yeah.
Just a minute. Just a minute. Then see.
अब एक करो ना थोड़ा.
Hello. Yes. Yes, sir.
Share the entire screen. Screen. Okay. Okay.
Screen entire PPT channel. Entire screen share करनी है.
वही
Screen share करनी है. It is coming, no, sir? Yes, yes.
Can you hear Dr. Krishnan? Ah, okay.
Next. Okay, sir. Okay, sir.
Yeah. I'm sorry for the inconvenience. Yeah, the first slide, few slides were basically showing that the temperature has been warming, and because of the greenhouse gases, and they are in the projected in the future also this temperature rise is going to be there. And because of this, some of the wet areas are going to get wetter and the dry areas will become drier. One of the important consequences of the temperature increase is the water vapor, which is projected to increase by about 7% per degree warming. And this has a direct consequence on the frequency of heavy precipitation events. And so with a 2-degree level warming, precipitation is projected to increase by 14%. But when you come to the Indian monsoon region, the question is, how will it affect, how this climate change is going to affect, global warming is going to affect the heavy precipitation events in our region. This is a very, when we talk about the Indian monsoon, it is a multi-scale interactive phenomena where rainfall is, we have rainfall along the Western Ghats, heavy rainfall also over central India and the Myanmar coast, and also along the Himalayan foothills. And rainfall is produced by various synoptic systems, low pressure systems, organized convection, embedded mesoscale convective systems, and also these low frequency intra-seasonal variability which contribute to the active and break monsoon cycle. And we should also remember that the Indian monsoon is being influenced by ENSO. And so the question is, what happens to ENSO? Because ENSO can be in a warming climate. So in my talk, I will briefly touch upon some of the examples that we have seen, recent precipitation extremes, water that understand their causes and teleconnections, feedbacks, and there's a climate change signal. In June 2013, we had the Uttarakhand event. It was a big, heavy, one of the heaviest rainfall events, and it caused massive flooding over northwest Himalayas. And in 2010, we had the flash floods in Leh. And this was due to the mesoscale convective systems over the high terrain. And Gujarat and Western India have been recently experiencing several rainstorms. And I'll discuss briefly about that. And lastly, I will touch upon the 2022 July-August heavy rainfall over Pakistan, upper Indus Basin, and a similar thing happened in 2010. So this is the very heavy rainfall of on June 16th of 2013 in Uttarakhand. And in this paper, Vellore et al., they analyzed 34, composite of 34 such heavy rainfall cases. And it turns out that many of this, so during this time, there was a low pressure system that formed over the Bay of Bengal and quickly moved westward. At the same time, there was a very deep trough all the way extending from the polar region. It was a very, very deep trough in the, you could see that at the 500 millibar, 200 millibar, and a very strong interaction between the monsoon and the extratropical circulation. And so this was a paper by Bob House et al. It shows how the water, this is the movement of the low pressure system, you can see, and the trough also is intruding southward into this region. The water vapor anomalies are enhanced. So this is the perfect spot for triggering this type of heavy rainfall in the Himalayas. And many stations, and being in a high elevation of 1,000, many of these stations at very high elevations, rainfall amounts were almost 400 millimeters, one day rainfall, 24-hour accumulation rainfall. And so they can lead to a huge amount of flooding. That is the main point. The another important case is the Leh flash flood that happened in 2010. Leh is basically a kind of a desert region, and this happened immediately after the 2010, 1 week after the heavy rainfall in Pakistan. This flash floods happened in the Leh Ladakh region, and this study by Bob House, then what they looked at the meteosat satellite data, and they found that by the afternoon time in the Tibetan plateau, the land gets heated up, and these mesoscale convective systems are forming. And these mesoscale convective systems, they move westward. These are diurnally generated due to the heating of the land. And as they move westward, and if there is a flux of moisture coming from the Bay of Bengal, that can trigger this very heavy rainfall near the clay region. So they said that even in there could be a very unusual development of mesoscale convective systems from these diurnally generated convective cells forming over the Tibetan plateau. So where there's an interaction between this moisture and this MCS. And more recently, we have seen in Gujarat and Western India, this was in 26-28 August 2024, a huge rainfall over Western India. In fact, there was a deep depression, and this is on 28th August 2024. And this depression actually formed over somewhere in the central India, slightly on the western side. And this is a track of that system. And in fact, IMD had issued red alert also for this system. And also these systems were very nicely forecast by our weather prediction models as well. And later on, the system went on to become a kind of cyclone, but later on it weakened, the Asna cyclone in the Arabian Sea. And so the point is many of these monsoon depressions, this is a paper by Dar et al. They looked at some of the most severe rainstorms of India. And this is one such rainstorm in 1941, which caused more than 950 millimeters of rain in one day in Dharampur near Surat. So these depressions, they form in the bay and they move westward, and they can really produce massive amount of rainfall over this region in Gujarat, Surat, and Mumbai. And in fact, we have looked at, and this region, it's not only because of the monsoon depressions, there are also these metropospheric cyclones where the vortices are seen in the metropospheric levels, but they can produce very huge amount of rainfall. So 3-day accumulations can be something like even 700 millimeters of rain in 3 days. And so these vortices are mostly confined over the Gujarat region. They're mostly stationary, quasi-stationary. And when they form, you have this very large-scale organization of a convection, and the small mesoscale convective systems, you can say embedded convective systems in this. And they give this very heavy rainfall. So we understand that this kind of a MCS, due to this northward propagating cloud band is there, and within that you have these MCS mesoscale convective systems. It because of the type of heating associated with this MCS, it gives a very strong metropospheric vorticity. And what we are finding is the number of rainstorms, this is over Western India, the number of rainstorm events over Western India, it hasn't increased so much, the number of rainstorm events. But when we look at the time series of number of rain days, the rain days is basically the duration. The duration of rain days over Western India has increased, has shown a statistically significant increasing trend. And so if the rain days are going to continue during the rainstorms, the duration is going to increase, then it has a potential for flooding. And this particular event lasted for more than 19 days or so in 2019. And it turns out that when you look at many of these rainstorms over Western, we made a composite of these long-lasting days. It turns out that many of them are related to a kind of a positive IOD type of situation, where you have cold sea surface temperature anomalies in the Eastern Indian Ocean and warm anomalies in the West. And you have a very strong cross-equatorial flow of moisture. And basically the water vapor is, you can see, there's an increase in the water vapor over this region. So there is a very large scale vortex that is forming over this region, and that is supporting this convection. Finally, I'll come to the Pakistan floods. Why they were so extreme in 2022, and looks like it could be a climate change signal basically. And so in beginning of May 2022, temperatures were as high as more than 40 plus, and people have seen that the glaciers also melted. That also contributed to the runoff. So the global warming signal is also now we are able to see that the heat waves were also very unusual. And on top of that, the monsoon also, there was an early arrival of the monsoon. So many factors have contributed, they appear to have contributed. But one of the important thing is it was a very strong La Nina event. In fact, 2020, 2021 and 2022, there were three consecutive La Ninas, what is known as a triple dip La Nina. And also in a warmer atmosphere, you can have more moisture, which means that you can have more extreme events. And you can see that this is during the 2022, the La Nina was very, very intensified. The West Pacific, we had very strong trade winds here, and strong cooling in the Eastern and Central Pacific, warming in the West Pacific, also in the Eastern Indian Ocean. Very strong gradient in the sea surface temperature, east to west gradient. And so the West Pacific subtropical high was very much intensified. Also, it extended more westward, and there was a flux of moisture, taking the moisture even from the Arabian Sea and also from the Bay of Bengal into the Pakistan region. When you look at the pre-monsoon months, it's during the May and June, before the rains, the land is it's heated up, it's very dry. So air is basically sinking here from the Afghan plateau. And so this is again from House, an earlier study. So so you have basically here you have the warm ocean, moist air coming from the ocean, and you have dry air sinking from the north. And so when the moist air, when the dry air sinks and the moist air rises above it, you can have development of deep convective instability, and this can lead to very intense clouds. And now several studies have shown that the climate warming has contributed to the record-shattering 2022 Pakistan rainfall. There were several depressions that formed. LPS activity was substantially enhanced. This paper has discussed, you et al. And in a warming climate in the future, this region in the Pakistan and other areas are going to experience more heavy rainfall and flooding because of the increased synoptic activity. And they're also able to attribute that climate change increased extreme monsoon rainfall, flooding highly vulnerable communities in Pakistan. This is when you look at the temperature, because as I said, in 2022, we had massive flooding, but also in 2010, but the scale was much more enhanced in 2022. You can even see the warming the surface temperatures in May 2022 was much higher compared to 2010. And there are also several tracks of several monsoon depressions that formed during 2022. Several papers have recently come out which indicate that the intensified La Nina gradient, that is in 2022 there was a very strong La Nina, and also there was this extratropical pattern, circulation patterns. They have, and they not only gave rise to this heavy rainfall over in upper Indus Basin, but also a kind of a dry condition over the Yangtze River Valley of China. So you have a kind of a pattern characterized by Yangtze River Valley drought and Indus Valley, Indus Basin flood. So this La Nina also joins to be, turns out to be an important driver of this heavy precipitation event, especially over West Asia. So one of the question is, what will happen in a warming climate? Are we going to go towards a more like La Nina state or a El Nino like state? Recent studies are showing that this is a paper by Seeger et al. In Nature Climate Change in 2020. They have suggested that in the last 50 plus years, as the temperatures have increased, the global warming has increased, the Pacific has moved more towards a La Nina-like state with more warming in the Western Pacific and cooling in the Eastern Pacific, and also strengthening of the trade winds and increased precipitation in the Western Pacific. And so the question is, when we look at the monsoon precipitation changes, models are indicating that in the future we will have more rainfall. The intensity of rainfall will increase over India, different scenarios, but there's a lot of uncertainty across the models, and we need to reduce the uncertainties. So in summary, what I want to say is the monsoon precipitation extremes in a changing climate, they have major impacts, severe impacts. And on the one hand, you have extreme rainfall, but there is also many areas have water scarcity, and which is affecting almost 40% of the global population. And water-related disasters account for almost 70% of all deaths related to natural disasters. This is from the World Bank. And the monsoon precipitation extremes, major cause for both not only floods, also droughts over the monsoon and tropics. And they pose enormous challenges. And I discussed some of the cases like the Uttarakhand, the Pakistan event, and Western India, and so on. And the drivers of extreme precipitation are, one is climate change we are seeing, also the tropical sea surface temperature gradient in the Pacific. Because if the La Ninas are going to become more intense, it is going to have an impact on the extreme precipitation, and how it is going to affect all the monsoon depressions and moisture transport and the mesoscale convective systems is going to be important. And recently, I know Vizag also experienced a continuous heavy rainfall due to the low pressure systems. And so how do we address this problem? We have to improve our scientific understanding, also our ability to predict this heavy precipitation in a changing climate. And we need to have an earth system approach. We cannot just look at only the atmosphere, because when we are talking about because we see that the ocean is very strongly coupled to the atmosphere, as well as the processes happening on the land. Because on the one hand, you see the upper Indus Basin having floods, and in over East Asia, it is in the Yangtze River Valley, it is drought. And so you need to have this kind of understand the interaction among the different components of the Earth system. And we need R&D on detection, attribution, and prediction of extreme events. And because if you want to do any specific extreme event, you have to do a large number of large ensemble experiments. Also, we need field experiments to have more and more observations, strengthening of international collaboration, education, training, and research. We have to enhance our early warning systems. And also we have to improve our satellite retrievals of the vertical profiles of water vapor, winds, and data assimilation. They are going to be key for the prediction of these extreme rainfall events. Also, the high resolution models are will become a very important necessity with improved physical processes. And also we have to link research to operations and applications. And it has to be linked to various sectors. And so we have to, it could be agriculture, it could be transport, disaster management, and so on. Yeah, thank you for your kind attention.
Thank you, Dr. Krishnan, for the nice presentation. Now I'd like to go to audience with, are there any questions? Can you hear Dr. Krishnan?
Hello?
No, he's not able to hear.
Hello, Dr. Krishnan? Hello.
Done. Close to that. Okay. Okay. Actually, the questions
Can we
maybe
go now?
you can chat online. Can you hear Dr. Krishnan? No? I think he's on mute. Dr. Krishnan, you are on mute. No, he's on mute. He's on mute. అక్కడ మ్యూట్లో ఉంది. I think the session is over. Now let's go for the next presentation. It will be Dr. GVM Gupta, Director CMLRE Kochi. He is going to give a presentation.
Good afternoon to everyone. Many speakers used to tell that this session after lunch, especially after an online talk with some technical issues, is always a problematic like this. But my topic is also slightly deviated to August audience available here, but I will try to be brief and then as quick as possible. Title is on Blue Economy Towards Viksit Bharat 2047 and sustainable utilization of how that marine living resources can help to boost that blue economy. Few aspects. On the larger perspective, the blue economy, since yesterday onwards, many speakers have already spoken. So I will not get into that most of the details. In fact, those presentations have made my job little more easy. So I will not go too much into that. So small genesis about CMLRE, those who doesn't know about it, it's almost like a 40 years old institution with 85. This has been set up as a Sagar Sampada cell and as a subordinate office. Then in 10 years down the line, it has been elevated to an attached office. And then further 5 years down the line, it has been renamed as Center for Marine Living Resources and Ecology. And since then, she is working with Pan-India on the marine living resources, and then a beautiful campus has been established in 2020. And fishery oceanographic vessel Sagar Sampada is exclusively attached to this center. So that will be the catering that all the marine biological studies that this country needs, especially in the deeper waters, more so on the fishery aspects. So the mission of this institution is very clear. that it should do that, stock assessments or otherwise mapping and where the resources are available and other things, and within that EEZ and outside also. And with the vision to give the policymakers a clear direction of where the resources are available and what would be the best way that the resources can be sustainably harvested and conservation measures have to be given. And these are a few of the areas where currently this institution is working on: biodiversity ecology, fisheries resources and habitat assessment, marine ecosystems and dynamics that marine ecosystem processes, and some societal activities, especially on ornamental fisheries things, and of course a deep ocean mission where the biodiversity is one of the vertical of 3 that we have been taking up. Blue economy, yes, it's now started in 2012 at Rio de Janeiro, and then this is with the UN Conference Sustainable Development. That principle has been emerged more than a decade back, with a clear-cut definition of ocean-dependent economic development to improve the quality of life of people. And then with the principal targets of 3 principal targets: low carbon emission, resources efficiency, and social inclusion. That means public participation, people participation, inclusion. So these are all the various areas: renewable energy, lives of all people, sustainable fisheries, shipping, then job creation, recreation, tourism, coastal protection, pollution. These are all the aspects which have been covered, and then I don't go much into the details. Of course, again, the blue economy would enable to achieve 10 global targets. These are all the 10 targets which, sorry. So these are all the 10 targets. One is on marine pollution, product resources ecosystem, then reduce ocean acidification, that is one of the major aspects, sustainable fisheries, conservation of coastal and marine areas, fishing, then pollution aspects, scientific remedies, small scale fisheries support, that is more important, MSMEs which we have been talking about. These are all the areas. And then blue economy is almost like globally it is a $3 to $6 trillion economy. And that is what is more important. And what we are seeing as of now is only that, that we are going to deal exclusively on the marine fisheries, though there are many areas, but we have been talking about. And then why we are all more important is that our Honorable Prime Minister has made it very clear. He has made it symbolic that with the Indian flag, where the central chakra is that central focus of economy that drives. So it's very clear that this is the main area where we have to do that. And 7th largest economy in the world, that currently it is almost like $4 trillion economy, which is now going to be made it to $8 billion economy in the future to come. And this is something about 2,516 billions of economy. That is what by 2020 that estimates. In that the fisheries sector is contributing to almost around $120 billion. That's it. But major task goes to tourism. But I'm not touching that. Restrict my talk only to the living resources and fisheries. And more here, when we talk about that, there is great potential for that living resources fishery point of view, that economic and food security, which is very, very important, because food security is the one which we need to look into that. And sustainable development is another point, because there is a large amount of over exploitation is going on, but the remedial measure is only to create, harvest the resources only through sustainably. And then how to enhance the resources, if not naturally, or at least through artificial measures, like that mariculture activities, which is the major thing, without affecting that environment much. So that can boost the GDP of that country. So capture fisheries and mariculture is the major thing that is going on. If you look at that Indian perspective, CMFRA and NAOT, they have been doing this cage culture fisheries in the coastal waters, and they are successful, and then doing a lot of potential to that. It is feeding. But the most important aspect is offshore fish farming, which is quite possible. Large scope is there in Indian country. In fact, we have not entered into that offshore fish farming, But that is the area where there is a lot of potential is there. Countries like China, Norway, they have been doing it, extreme, good business, and then a lot of technological development has been made it towards offshore fish farming. India had to make a beginning into that. And biotechnology and pharmaceuticals, that's the most important, because the organisms which live in that very harsh conditions of the deep sea, where the dark light is not there, and then very extreme cold and low oxygen conditions when they are surviving, they have habituated and then acclimatized to those harsh conditions, and they develop some genetical characteristics that will adapt them to those harsh conditions. Those genetic characters would be very useful, and then the compounds which we can extract it from these organisms will form a very beautiful medicinal properties, medicinal uses, everything. A lot of technological prospects are available for those things. Of course, tourism is the biggest one, that I'm not again going to that. So in the marine biology, in the Indian perspective, if you look into that, the marine fisheries, mariculture, pharmacology, tourism, these are all the major aspects. But the challenges what we have been seeing through climate change is all ocean acidifications, coral reef bleaching, harmful algal blooms, and then effects of anthropogenic activities like the habitat destruction, pollution. These are all the things. But the most typical parts when we are talking about the biodiversity is that diversity assemblage pattern, because in a particular environment, whatever that animals are living, how that they have the assemblage patterns, and then their regime shifts through the climate change, and alien species, that is another which destroys that local endemic species, environmental impact assessment, and the most important task here is the marine protected areas that will bring the conservation of these resources in a sustainable way. Look at the global point of view, almost like 2.5 lakh marine species have been recorded all over the world in the old global oceans. But in the Indian scenario, if you just look at that, the down picture, it's only as of now we could able to reach now almost like something around 20,000 records have only been made it. So a lot of potential is there. In fact, tropical waters are rich in biodiversity compared to temperate and subtropical waters. So, but yet our record and our efforts are still not enough to reach to that anywhere near to that global level. We are not even, almost like 10% of the inventory is only been made in our waters. So the goal is that towards the conservation by 2030, all that according to Montreal Conning agreement, by 2030, 30% of the oceans need to be conserved, and 30% of the degraded ecosystems have to be restored, and the invasive species have to be made to half, cut down to half. This is the goal by 2030. It has been set, and then most of the nations have to comply with this particular thing. But except few countries, this target is a distant dream to many people, many countries. But we are in the process of trying to do that. So global population, if you look at that, protected areas, 8.16% is only there as of now. National waters has got something about 19%. High seas is very, very limited, almost like just 1.5%. As of now, that protected areas have been declared it. Like, where do we fit? See, as a similarity, and as part of the true similarity, where India stands as of now, or Indian waters, where it stands. So we have developed a system called Indian Ocean Biodiversity Information System, where India is similar is an Indian node for that Ocean Biodiversity Information System. And then we have developed an Indobis.in website portal, where any researchers across the world for that Indian Ocean region, they can contribute their inventions, their records, their biodiversity records in this particular platform. And as of now, more than 1 lakh records have been documented by Similary, and then a lot of DNA sequences which have been already mapped it, and then they have all been made available. In fact, our biggest contribution to blue economy is that many people doesn't have that access to the deep sea samples, whether it is a deep sea water or deep sea sediments or deep sea biota. They are not available because they have a lot of bioprospecting potential. So we maintain all these repositories, and we try to do services to the people, like who wants to do the academicians, researchers, or entrepreneurs. We provide these rare samples to them, and then they can develop the technology to bring up useful economic products to the country. So these are the challenges for us, because as I said, only one vessel is there with us, Sagar Sampada. For the 40 years, she has been exclusively rendering the services to document all these inventories, marine living resources in the country. But one vessel to 2.02 million square kilometers of EEZ is quite insufficient. So we need to adapt the new tools and technologies through AML and then remotely operated vessels. So conventional taxonomy has to be upgraded to technological tools to make it more rapid assessments, capacity store and process enormous volume of ocean data, because most of the things what we have been talking about last 2 days is more on that computational facilities and modeling efforts for the physics, and then more so on the biogeochemistry. But this biological data is too vast, and then it requires much more potential of storage capacities and processing capacities. Because the biological point of view, so far India has not invested much on that storing and then processing potentials. That is very, very important, because future is going to be the biology, and then on the biology, any investment, it gives more than 10 times of returns. So paucity of skilled human resources, it is still there. Capacity building is going to be one of the major challenge, which we have been trying to do that in association with many other institutions. And principles of stronger economy. So the three principles are the most important one: sustainable marine fisheries, mariculture, and prospecting. I will give slightly details. Like if you go by CMFRS 2022 estimates, total portion fish yield is something about 4.5 million metric tons available in the country. But annual ship landings, fishery landings point of view, it is just below the 4 million metric tons. So there is untapped potential is still available, but this is on the scientific records point of view. But that actual ground reality is something that fishermen always make a complaint that there are no fishes, enough fishes in the waters. So there is something that over exploitation is making a real matter. That is coming between the actual ground scenario and then scientists what they have estimated. So that why? Because that over exploitation is happening, because we don't know exactly that how much stocks are available and how much stocks have to be actually scientifically we have to derive how much how many boats have to be allowed for fishing, or how many each boat how much it has to do that fishing, the catch quota system. These are all possible scientifically, but it requires a lot of political determination, and then social responsibilities are there, social issues. So many times science doesn't get into that policy decisions, unless otherwise that happens, this war exploitation continues, and we will not be having a ground reality of that fishes are really available to the fishermen. These things continue like this. So deep sea and distant water fishery, that is an alternate point of view, because most of the coastal resources have already been overexploited, not much is available. The one way that we can get into the deep sea areas, and where that lot of fish potential is still available, except for the tuna, nothing much has been exploited as and now. So a lot of untapped potential is available. What we have seen is that in the slope areas, lot of demersal fisheries available. That means the fishes that are living in that sea floor, there are a lot of resources are available. That is from our past so many surveys, we have identified slope regions as another second hotspot of that fishery resources. So those can be tapped. And midwater fisheries also have got a lot of potential. Globally, midwater fisheries around 600 million tons is available, but in the Arabian Sea alone, it has got something about 100 million tons of resources, which is possible to be tapped. So potential living resources with challenges is that life cycles and then commercial values, lot of edibility, many things are important. So advanced technologies are very, very important for the harvesting and post-harvesting technologies. So this is actually the current scenario of how much the fishery resources have been mapped in that Indian EEZ. Though we have covered most of that in the areas, there are blank areas, but actually the maximum surveys have been done in the Southeastern Arabian Sea and Andaman areas, where the largest information is available. And we have seen that lot of new records, new species, A lot of pristine environments are available in these areas still. And now that in the deep ocean mission we have been doing the sea mount surveys, and we just completed 3 or 4 surveys, and to our astonishing surprise that the life that is we could able to see there, we are with 3 surveys we are expecting something about 40 to 50 new species that have been never discovered to the Indian waters. So that is the beauty of that biodiversity still yet to be explored by India. So mesopelagic fishery is nothing but that fishery which is available in that midwater fishery. This is the midwater fishery. So there is a lot potential. As I said, 600 million tons is the global estimate. Indian estimate is around 100 million tons. Still, it's untapped potential, but this is mostly in the high sea waters, not in that EZ water. Indian EZ also it is available, but that is something about what we have estimated is around 18 million tons. So something about 80 million tons is still available in the high sea waters, but India doesn't have a high sea fishing policy. There is that another bottleneck, a policy decision which is required. In absence of that, China and then many other countries are coming to our international waters, our adjoining waters, and they are doing large scale of fishing, which is also creating a security issues. So the government, to avoid that security issues, they are trying to come up with a high sea fishing policy now, but it takes some more years to make it reality. So another biggest requirement for the conservation of the fisheries is that not that when the animals grow up that we need to bring up some policy measures to restrict their fishing and all. What we are trying to is that where is the spawning, the fishes where they spawn and breed, and those grounds if you can able to identify it, the conservation starts at the early stages itself rather than going at that matured stage. So that is what, instead of waiting for the fish to become adult, we are looking at that when the fish started breeding itself, we are mapping that those grounds, and then that conservation is possible from the early stages itself. The governments can be given the advisories when and where that grounds of fishings are happening, and that will be very useful for the policymakers. And then we can bring up some amount of restrictions in the fishing activities in those regions in that during that specific periods. So high sea fishing policy, apart from Indian waters, there is a large potential in the southern oceans, in the Antarctic waters. Lot of fishery potential is available, and then India is a permanent member of Antarctic Marine Living Resources Commission for almost like 40 years. But we have never tapped that high cold water fishery in those regions. But it globally it is something about 1.2 billion US economy, and if you could able to tap it up, it's going to be a huge revenue. And now we are making efforts to make a beginning of this southern ocean fishery. We are entering it most likely in the next year. We are trying to go to that, and then we already had extensive discussions with Indian entrepreneurs, PMO office, as well as all the stakeholders, consultative ministries also. We are coming up with options of how to make a special permissions for going to the southern ocean fisheries, and next year we are planning to go, and then most of the bottlenecks are being cleared now. And just this is the fish stocks which we have been talking about, 2003 to 2009, from all the data sets, whatever CMLR has collected it through food web trophic approach, from small predators, small organisms, microscopic organisms to small organisms. Small organisms feed on the higher organisms. So as you go through that trapezoidal approach of that biodiversity, then the biodiversity stocks available is 4.32 million metric tons by 2009, but almost like 10 years down the line, they have been noticed to be almost like 5.12 million metric tons. But recent estimates are something showing that something still it is increased by around 6 or 6.5 million metric tons. But as I said earlier, scientific evidence is something different. Stocks are being increasing it, but corresponding to that increase of the stocks, exploitation is also going on much more rapidly and much more higher percentage than what is the stocks is increasing it. So both are not going in syncing way. So mariculture is the second most important. As I said that if you look at the global hunger index, India is at the almost like very in bad position, because Our hunger index is almost something about 16.6% of the population is undernourished it, as per the global index and the things. So fish being one of the main proteinaceous food for human consumption, so enhancing that stocks, if not naturally, through artificially, through these maricultures is very, very important. And then, and as I said, offshore fish farming has got a lot of scope, but it requires an industry to come. It's a big investment is required it, and scope is possible. Indian waters are very much suitable for that, but we are not getting into that. I'm not going into the challenges, but this is my last slide. So bioprospecting also, as I said, a lot of fish, deep sea samples like biota, then sediments, waters are all being stored by CMLRE, and then we are making it accessible to all the researchers and then community in the India, so that they can develop the products and then contribute to the blue economy of the country. And these are all that some of the agencies who are working on conservations of living resources in the country and across the world also. And towards this, we had drafted a vision document, and in that SDG 14 goals are the most criteria. So rapid mapping of deep ocean life, long-term changes of marine life, and biological permanent observatory, and offshore farming, and then southern ocean fishing. These are all the few broader areas we have listed out already towards making that blue economic potential for the country through the things. So the biology is the future, and science we need for the oceans we desire is the goal, is the slogan on which we have been working. Thank you very much.
Thank you, Dr. Gupta, for an illumination presentation on marine living resources and the status in the Indian Ocean region. Now, I'd like to ask whether there are any questions. Sir. Sir.
Thank you very much for the wonderful presentation. Not that you don't know, this is a general comment, not a question, please. You see, man has meddled with the above atmosphere, above the ocean, and we see its impact in so many ways, like floods, droughts. You said in India, the what you call poor feeding or malnutrition index is increasing about 16% compared to many other countries. It's quite high. And this could be partly due to the global warming, where the fertile lands are being replaced by very arid lands. And before doing any such experiment with the nature, whether it is atmosphere or the ocean or the upper atmosphere, probably now we have resources to simulate in a reliable model, if we make these changes, what will be the consequences. So before doing that type of really meddling with the real atmosphere or the ocean, can we not make an experiment to see what's its impact? Did anybody think about this? Please, thank you.
So that is where that SDG goals we have been talking about, Sustainable Development Goals. SDG 14 deals with oceans life below the water, but there are many other SDGs which have clearly defined the principles of developments in a sustainable way. Whether or not the policies are being screwed, we are almost like tuning to meet these SDG goals is what is more important. We have seen at the Hyderabad, in fact now that Hydra is demolishing many of the things. What you said is exactly the same case. When you are occupying the water bodies and then drainage and then flow patterns, automatically that the things gets. Now Vijayawada also we have seen the same thing. So these are all the things. Science is one way and then policymakers are doing the other way. They are not going together. Unless these two goes together, I don't think that science goes independently and policy goes independently. And our effort is to bring the politicians to listen to science, and then things will move on.
Yeah, since you said anyway, the politicians, I will make a comment. Global South is dancing to the music of the Global North. Sorry.
Thank you.
Dr. Gupta.
Yes.
Now, may I call upon Dr. Kamaljit Ray, scientist from Ministry of Sciences, to give a talk on that subject.
Thank you. So good afternoon to all of you. So I'm not from Andhra University, but like I know a lot of people, my colleagues, my teachers who are from Andhra University, and because of their good wishes, I'm here speaking in front of you. So I'll be talking about some of the climate actions which Ministry of Earth Science has taken up to support the climate goals. Yeah, next. This is. Yeah, so let us start on a positive note that global warming has really led to increase in frequency and intensity of extreme weather events, including extreme heat, droughts, floods, storms. But in spite of this increase in the events in the past decades, the extreme weather events are known to contribute only 0.06 of the global mortality. The extreme weather events are reported better than in the past, and the global mortality attributed to them has declined considerably, 93 to 98%, although that component is mostly because of the tropical cyclones. The prediction of tropical cyclones has improved in the last 2 decades, and thus this mortality rate has gone quite down. So this is a remarkable improvement in society's adaptive capacity, and also because of the early warning and better technology which has been taken up by the meteorology community all over the world and also in India. So on the positive side, weather forecasting has made extraordinary progress in the recent years with a prediction which is quite reliable within 48-hour period. So I'm just going to talk about some of the facts first, and then what are the steps which are taken by Ministry of Earth Sciences for talking about the early warning or climate change scenario. What are the steps which have been taken? So this is a diagram which talks about the last 50 years of extreme weather events. This is a disaster weather events data compiled by India Meteorological Department, and this is what we get as inputs from the state government. If you see 50 years of data, 50 years of extreme weather events, you can see the red line. It shows these events have been increasing over the years. You can see, and it's quite significant, the red line. But if you see the mortality associated with these extreme weather events, that has remained more or less same, or it has also decreased. The 2-3 peaks which you see, 2-3 peaks in green color are mostly related to the tropical cyclone, the mortality due to tropical cyclone. That is 1971, 1977, the Chirala cyclone in Andhra Pradesh. Then there is a 2013 Uttarakhand rains which led to a lot of mortality. Again, we have a Phylline cyclone in 1999. But if you take the mortality as it is, with the increase of population, the rate has decreased, even with the increase in these extreme weather events. So like these are all the extreme weather events. If we take together, you can see the deaths per million per year, they have come down. This is a decadal, sorry. Yeah. So this is starting from 1970, we have for various decades the decadal analysis. And most of the last 2 decades, there has been a decrease in mortality. But if you see the extreme weather events, they have increased. So if we bifurcate for tropical cyclones, floods, heat waves, cold waves, and lightning, we see an increase in mortality for lightning and heat waves. There has been an increase if you move over the decades. While it has considerably decreased for tropical cyclones. The tropical cyclones are better predicted in the last 2 decades, like almost after 2000, the death rate has gone down considerably. There has been a decrease in mortality due to floods. Also, there has been a decrease in cold wave, but heat wave and lightning are these 2 parameters where we see there has been an increase in mortality, and it has increased in the last 2 decades. So like some of the case studies I'm going to talk about, for example, Odisha super cyclone, there were 10,000 deaths. It was in 1999. I think that was the last cyclone which saw so much of mortality. Afterwards, the mortality has considerably decreased because of the coordination with the disaster managers, because of a better early warning. So things have improved for cyclones. Similarly, we had this extremely heavy rain in Uttarakhand. It led to around more than 5,000 deaths. And it is always one of the extremely heavy rains. It is one of the figures which account for the highest mortality in the last 2 decades. The heat wave in Andhra and Telangana. In 2015, heat waves prevailed over eastern and peninsular parts of the country, and there were human lives lost to an amount of 2,000 in Andhra Pradesh, and that time Telangana was a part of that, I think it was almost. So there has been, Andhra Pradesh has been particularly a hotspot of heat waves as per the data, and 500 deaths were reported in 1970, then 1998, 2002. We can say that vulnerability is also an important factor which is leading to these deaths in a particular state more in Andhra as compared to other states. Then again, cold wave in Bihar and Jharkhand led to a number of deaths. Similarly, lightning in Maharashtra. These are the states which are affected by these extreme weather events. So if we take the top mortality-wise, top 5 states for each extreme weather events, this is the scenario. And if we go for the total, then Andhra, Odisha, UP, West Bengal and Bihar. These are the states we have to worry about the most because of the involved mortalities, and we need to prioritize these states for developing action plans. So if we talk about WMO's early warning for all initiative, these are the 4 pillars which we need to talk about. First is disaster risk knowledge, detection, observations, monitoring, analysis and forecasting of hazards, preparedness and response, warning, dissemination and communication. So our part is mostly, the meteorology community mostly deals with detection, observation, monitoring, analysis and forecasting of hazards. So the early warning part is adaptability and early warning. These are the 2 things which this community has to mostly focus on. So next 5 years, the main initiatives which Ministry of Earth Science is going to take, I'm going to list all those. We are mostly focusing on predicting weather and climate extremes and development of climate applications based on monsoon forecasts, especially in field of agriculture, hydrology and energy sector. And the focus has been high resolution, short range predictions, predicting extremes, and using this forecast for the services of various stakeholders. So this is one of the most important thing which is going to come up. We are going to have a high power computing system with about 21 petaflops in IITM, NCMR-WF, and also some part in IMD. And mostly this is going to be operational by next month. This is going to really help us in having a very high resolution, skillful short range forecast for extreme weather events. There will be improvement in scale of dynamical models, and also we plan to have artificial intelligence and machine learning techniques which require a very high computing power. So this system is really going to help us improve the skill and also go for a better forecasting and early warning. Then a multi-hazard early warning system with India Meteorological Department. India Meteorological Department has already, we have a great system set for cyclone warning, but the similar system is going to be, it has already been achieved, I think. They have a decision support system which we have a SOP for extreme rainfall, we have for heavy rains, we have for cold waves and also lightning. So this decision support system is really helping the forecasters to achieve the early warning for all kind of extreme weather and also the other weather-related state-wise and also temporal and spatial-wise requirements of the various stakeholders. So this is another flood warning system which is adopted, implemented by these three institutes, IITM, IMD and NCCR. In Chennai, we have this iFlows, which is giving flood alert to the state government. This is very important for various urban areas, for urban cities. So we have to have a dense network of automatic weather stations, Doppler weather radars, and it helps in urban flooding and providing to the state government measures to overcome these flash floods and also the floods related to these extreme weather events. So we have urban meteorology mesonet coming up in Delhi also. This is at present going on, and by next year, this mesonet will be in Delhi and will be very useful in giving urban nowcast. About Delhi, we'll be able to give a nowcast every hourly. There'll be a DSS for floods. There'll be hiring of aircraft. We'll have airborne experiments. So this is something which is ongoing. Another is the atmospheric research test bed. IITM has come up with a research test bed facility in central India. Central India is very important from monsoon point of view because all the low pressure and depressions are passing over that area. And surely this test bed is going to provide a lot of observations for the meteorology community, for the students, for the PhD holders who can use this data and do more work on that. So this is what we are aiming to get from these atmospheric research test beds, which is established by IITM. It's a permanent observation facility, and there'll be, since it is a monsoon core zone, you'll get a lot of data and you'll be able to work in more detail, obtain some of the processes which are controlling the monsoon core zone and its movement. So these are some of the instruments which are going to come up this ART facility. And this is for, this is information for all the students out there who can use this data, who can get these observations and then work on that. Similarly, we have an integrated Himalayan meteorological program for Western Sedentary Himalayas. This is, we have put almost 10 Doppler weather to understand the Himalayan region, to understand the meteorological conditions there, to understand, to improve the skill of the forecast in that area. And in addition to these Doppler weather radars, we have almost a set of automatic weather stations. And in this new mission program, we are going to have more instruments like radiometers in this area as well as other parts of the country. So as I told, we're going to expand it by almost 60 to 70 in next 2 years. At present, we have 35 Doppler weather radars, and these Doppler weather radar data is something which is a very complex data, but very underutilized. So the students, I would request students to please use this data, to obtain this data and use it in your models, use it in your studies. This data is like we're going to have almost 50 to 60 Doppler weather radars all over India, and that is surely going to help you achieve some of your meteorology related tasks which you need to take up also. So some of the challenges which we need to talk about is, although studies indicate a decrease in the frequency of TCs, tropical cyclones, but the cyclone intensity and precipitation rates may increase. So further projections suggest that rainfall associated with TCs is likely to increase by 20%. So the tropical cyclones track is mostly is predicted well. You know, if 5 days ahead we are able to say where a cyclone is going to strike or a cyclone is going to make a landfall. But again, the intensity of the cyclone and also the rainfall associated with the cyclone is something very tricky. So we have seen also in some of the cyclones, the rainfalls are something which are difficult to predict. So we need to work more on that. We need to work more on estimation and forecast of the associated rainfall. Again, heat waves are the third largest contributor to the mortality in India. contributing about 12% of all mortalities due to extreme weather events. So this is also something we need to, this is a challenge which we have to take, how we can predict these heat waves in a better way and how we can educate the public about this impending weather. So the heat mortality in India has increased by 62%, and states of Andhra and Orissa have the highest mortality rate per year per million at a population of around, like it has increased by 3.3 to 1 for Andhra and Odisha respectively. So again in India in the last 2 decades, high population states like Andhra, Bihar, Odisha, Assam, Maharashtra, Kerala and West Bengal suffer from maximum mortalities, and we need to prioritize these states for developing action plans. So in the end, I will summarize by telling that the floods and tropical cyclones have been the 2 major disaster causing deaths, although heat waves and lightning are gaining importance. They have increased in the last 2 decades, but I would say that, yeah, there has been a reporting, better reporting in the last 30 to 40 years as compared to the earlier years. So the reporting has improved, and yeah, that can be one of the factors that we have better data in the last 2 decades. Again, the contribution of extreme weathers events to the overall mortality is very low, that's 0.038, not only in India, but globally. The contribution is very low and it has gone down further, like it has gone down by almost 85%. The mortality rates have decreased immensely. But there has been a significant increase in EWEs, which we need to control in a better way. We have to have a better disaster management plan, a better early warning, weather forecast, so that this becomes negligible, the mortality becomes negligible. And as I've already told, the high population states like Andhra, Bihar, Odisha, Assam, Maharashtra, we need to prioritize these states and need to focus more on adaptation and mitigation in the coming times in order to counteract the effects of climate change. Thank you.
Thank you, Dr. Kamaljit, for a very comprehensive presentation on various activities of MOS, particularly in atmospheric sciences and services. We have one quick question. We have time for 1 or 2 quick questions.
For a change. Yeah.
Ma'am, it's a very nice exposition given for this. I just want to bring to your notice the sad things happening because of heat wave and the lightning. The statistics what has been shown also, in Andhra also more than 2,000 people have died. What I feel, as you said, the reporting part has improved, no doubt. The IMD and the disaster management and various sources government is reporting. But what I feel is, if we discuss and get the predictions, but it is not going to the society. The society is not becoming aware. For example, heat wave is there. People do get the report nowadays on the mobile also. We get an SMS, lightning SMS. Lightning, of course, it is very difficult to prevent it because suddenly you may get caught. But heat wave is such a thing that people can take precaution. They can remain indoors, but they don't do it. So it becomes the responsibility of the people who give these reportings, like, you know, we find these things, but we have to take it to the society. So the science should go to the society. So in that way, certain steps have to be taken. That's what I feel.
Yeah, so that's a very valid point. The vulnerability is, as I told, no, that's something like the labor who are working in the fields, people who are very poor, who are earning day to day through that day's work. It's very difficult to tell them not to do work for that particular day. It's not good for your health. You see, bringing them, like even for during cyclone, evacuating people, very poor people who are day to day dependent on the work they do, daily wage workers. So it becomes very difficult. So So those are some of the things, no? Those vulnerabilities are there. Although heat waves are quite well predicted, nowadays we know if the heat wave is going to affect a region, and it's very well covered by the newspapers and also NDMA. So that has helped, but again, since it is something related to more with the people who are open in the open fields, it becomes difficult to reach each and every person. Yeah. Yeah.
Sir, you
Yeah.
can
So
discuss
that's
that
why-
later. You can
that's
discuss
why,
this later.
with health department
We are
also
completely
we
out of
have-
time. Maybe just last question. We are completely.
Yeah, a nice presentation, ma'am. I have a quick question about this mesonet and urban meteorology slide, what you have showed. What is your comment on the interaction between global climate change trends and a local urban heat island? Like, for example, I have heard in Hyderabad nowadays it's more raining more, the precipitation is increasing. So, did you do any analysis, or is this common in other cities also in India? What is your opinion on this interaction between climate change and local urban heat island because of pollution or increasing population?
I think that's a very well established thing. You see, urban islands do contribute. That's why this talk about having urban meso networks and all this talk about the building, how are we going to have buildings so that they don't add to the urban heat island. So that those things are very well established. So we do acknowledge, and we have to acknowledge. These are not facts. These are facts which are not something new.
Yeah. Just adding to that.
Yeah.
So why do you think it's a lot of apartments, and so are there no statutory?
Sir, you can discuss that question later.
Yeah,
Maybe.
exactly. These are all, like he told before me, our speaker, Dr. Gupta told. So there are two things, policy and science. So they have to go together. So we're trying our best. We're trying our best at the ministry level to see to it that the policy makers take this science into confidence and implement it in all the other things. Like, because weather and climate change is something which will affect everything. So whatever is happening, they should have policy, they should have inputs from the climate community. Ministry of Earth Sciences should be a part. So that's what we are trying, so that they are educated and they take policy matters accordingly. So that's an important thing, and we're trying our best. Yeah.
Thank you, Dr. Kamalji.
Thank you.
Once again. Let's give it. Now I'll call upon Dr. V.V.S.S. Sharma, Scientist in Charge, National Institute of Oceanography, RC Visakhapatnam.
Good afternoon to you all. And since yesterday we were listening several talks talking about the current trends in the atmospheric processes especially. And there are some good news that the monsoon we could able to predict well, and even the cyclone tracks are also getting better in the prediction. I'll try to give you few glimpses on how we are trying to do it in the biogeochemistry with reference to the climate change. And there are several fallacies here. Because of them, we are scaring the people, even though they may not be realistic. So hence, about 18 months back, about 60 to 70 scientists all over the India, we met together at Kochi, and Dr. Gupta actually hosted us, where we discussed that where we are with reference to the projections of the biogeochemistry due to climate change. So I'll try to, since it's only the 20 minutes, so I cannot able to tell you the entire outcome of that meeting, but I will try to give the few glimpses where we are in the prediction of the biogeochemistry change with reference to the climate change. We all know that the ocean is warming, and the Indian Ocean is warming much faster than the other two basins. As a result, one would expect that the oceans are getting stratified because of the warming, and we have a nutrients below about 50 to 60 meter depth, and those nutrients are not coming to the surface, and therefore one would expect that primary production or the chlorophyll or the phytoplankton biomass is expected to be decreased. This is a simple anticipation, everyone can able to do that. Based on that, several papers have been published in the past, even in the good journals like in Science. So this paper actually taken the data from about the, I don't know, it's not working, this one. About the 6.3 years of the data has been taken up, and they showed that the primary production in the Arabian Sea is increasing tremendously because of the Eurasian landmass actually becoming warmer, resulting in increase in the summer monsoon intensity, resulting in increase of the production, which is something very good news. Then extending the data for the 12.3 years, double the data, and then they try to look at the trends. Then they said that no, this is not a climate change trend. It only the decadal change. So therefore, there is no increase of the chlorophyll. Then some more data has been taken, 16 years of data. Then they said, no, there is a serious decline of the primary production in the Arabian Sea, but not in the Bay of Bengal. So therefore, the fishery production is expected to be decreased so much here, even by almost 25%. So that will have a significant impact even on our GDP. Okay. All these ones, what they were talking about by taking the chlorophyll as a parameter to talk about the primary production, linking that into the fishery production. The chlorophyll, for those who do not know, it is something like a blood in our body. You know that in all our bodies, on average, we have 5 liters of the blood. It does not mean all of us will work in the same way. That's what the primary production. Okay. So therefore, if the chlorophyll is increasing or decreasing, does not mean that primary production should increase or the decrease. Okay. It's one of the parameters, not the sole parameters to control the primary production. Let us go into the models, what models are talking about. Some models, many of them are saying that, okay, they were decreasing. The blue color on the region, there's a northern Indian Ocean. There is a decrease of the primary production. Okay. Where in the southern also. The other models, here this is the IPCC model, they are also showing that all this purple color is a decrease of the primary production. Similarly, the RCP 8.5 related models by the IPCC also showing there is a decline in the primary production by almost 10 to 25% in this region. Then, if you look at the IATM model, where actually they showed that using the 16 years of the data, primary production is decreasing only in the Arabian Sea, but not in the Bay of Bengal. What they say is that a lot of nutrients are coming from the river discharge, okay, both nitrate and the phosphate. Unfortunately, all of us, we are struggling so much to input the river discharge into the model because we don't have the real-time river discharge data, and we are using only alternative ways to get the river discharge data. The second one, when you go into the biogeochemistry, we require to know the concentration of some chemical consistent in that. We don't even know the river discharge data. How do you know that even the chemical consistent in that? So therefore, we are adding some numbers into that, trying to run the model and saying that a lot of nutrients are coming here. That is why even though climate change is happening, decreasing the nutrients coming from the subsurface, but the rivers are compensating, so therefore no production change in the Bay of Bengal, okay, which are little away from the reality. So therefore, that is what they say, that there is no production change happening here mostly, so because of compensation by the river discharges. Let us look at the real data, which is coming from the Northern Indian Ocean by the different programs. Unfortunately, we don't have any time series observations for the long time. But whatever the different programs that have been collected on the seasonal one, when you look at this data, look at the standard deviation, we don't see any much variability in the data, even though it is not time series data. Okay? So models are, observations are showing that there may not be so much variability in the production, but models are showing that there's a serious decline in the production. So as I said that all these models, they take change in the chlorophyll, but we must look at change in the net primary production. But these two trends are actually contrasting to each other sometimes. So let us look at how the atmospheric pollution is causing the problems or the warming or the climate change related issues to the ocean. We know that above the northern India and above the China, these are the two regions where the maximum atmospheric pollutants are being released, mainly the anthropogenic pollutants. By the seasonal change in the winds, all these pollutants actually gets deposited in the northern Indian Ocean. And you see, this is the anthropogenic AOD, which represents the atmospheric pollutants. You see, they're always very close to India. They're much more thicker. And going away from that, actually it becomes relatively thinner. But this line, within this black line, that is actually significant. So you see that wherever the trends, this is the SST trends, where we have the more anthropogenic aerosols, the trends actually relatively weaker. If you go into the monsoon, the anthropogenic aerosols are much less there because you have a precipitation that removes the most of the anthropogenic aerosols. That time you have the much higher warming over the northern Indian Ocean. But we have a dust aerosols here, mainly coming from the bigger winds are coming from the southwest. They are bringing the dust from these desert areas, but they won't cause much impact on the atmospheric temperatures. So they add some kind of a blanket so that not much of they will try to inhibit some of the solar radiation coming from the sun. So if you look at this in terms of the chemistry point of view, most of these anthropogenic aerosols, they bring some nutrients like a nitrate, iron, little bit of the phosphate and so on. And we have a lot of data collected, not only by us, by many of the Indian scientific community. All we put together and try to make some kind of a climatology of the atmospheric nutrients deposition rates. So the significant amount of the atmospheric nitrogen is getting deposited. It is much more higher in the northern Indian Ocean. Now, when you look at the net primary production, this is not the chlorophyll. It is calculated using the light and the chlorophyll and temperature and many other things taken into the consideration. North of 12 degrees north, we don't have the much productivity variations because where you have the lines, that is where actually the significant variability you have. So otherwise, we don't have the much variability. You see in the down south of the 12 degrees north, we have a decline in the primary production during the winter, and the same with the spring and summer and fall also as well. Only in the south of the 12 degrees north, only the significant decrease in the productivity you could see for the last 2 decades, but not so much in the north. It seems that maybe the decrease of the vertical mixing, which we computed actually using the models, seems to be compensated with the deposition of the atmospheric nitrogen, resulting in not so significant changes in the primary production, including along the Indian coast, where in the certain zones even it is increasing. So therefore, what models are saying, without having this kind of a processes, that it may decline, it may having an impact on the fisheries, that may not be so serious issue in that way. Then we'll try to look at, okay, how best is the net primary productivity models, because we have several models. We have a VGPM, CBPM, APLA, and CAFE and OCCCI models. Unfortunately, all these models are giving the different numbers of the estimations by these models. When we try to draw a trends, you see that each of them having what we finally could see, that even though so complicated this figure is, all models said that only this region, the productivity is decreased, has been shown by all models. Otherwise, some models are showing that entire tropical Indian Ocean seems to be decreasing the production. Some models show that this region production is increasing, and only for one model shows that this production is decreasing here and so on. There is no consistency among the models, even to show about the NPP, how it is doing. Then, similarly, you go with the oxygen minimum zone. For those who do not know the oxygen minimum zone, that below the 100 meters, oxygen concentrations in the ocean goes almost close to the zero. We call them as the dead zones, where very hardly any life is existing there. So then we'll try to see that what is climate change is making, whether the dead zones are expanding or shrinking or whatever it may be. Model shows that, so observation shows that only in certain zones between 15 degrees north to the 10 degrees north seems to be expansion of the oxygen minimum zone. North of that, there may not be so much variability. Regional model shows that no oxygen minimum zones are expanding because of the warming. Global model shows that there is no change in the oxygen minimum zone in the northern Indian Ocean. The white zone is no change. Okay. There are a lot of confusion among the observations, regional models, and the global models. Then, similarly, the IPCC models are showing that in terms of the ocean acidification, which is one of the serious problems which I always discuss on, entire Indian Ocean acidification is happening in the same rate. There is no variability with reference to the space. That's what the IPCC models are showing that. Using the 2.5 decades of the data in the Bay of Bengal, we could see that red means where the pH is increasing, the blue means where the pH is decreasing. A lot of spatial and seasonal variability has been seen associating with the increase of the discharge, which brings actually high pH waters. These could not be captured by the models. Why these models are performing very bad? It's not just because I'm talking about the Indian models, I'm talking about the global models, because we have evaluated IPCC models, how best they are performing in the Indian Ocean. One serious problem we have that our climatology of the nutrients, for example, if you take, they are very bad. This is the kind of a data what we have that has been collected for the several decades. And most of the Indian data never goes into the global climatology. There may be remaining in the PI's accounts or otherwise maybe in the somewhere in the Indian data centers. They're not going into the climatologies. On the other hand, we never have a biological climatology, like except the chlorophyll. We don't know what kind of phytoplankton we have, what kind of zooplankton we have, what are the bacteria and so on. We never have such kind of climatologies. The present models, you all know that actually the backbone for the model is the climatologies, but the present models are running with this kind of a bad climatologies. Then we try to look at that how best models are trying to perform with reference to the nitrogen, because that's one of the important nutrients. Typically, nutrient concentration will be very low in the top, because this is the light zone where the production is being taking place. The nutrients have been removed by the phytoplankton, and they start increasing. This increasing zone we call it the nitroc line. The depth where nitrate starts increasing is very important, because if any physical mixing occurs, if the mixing happens up to the 60 meters or the 80 meters, that determines how much of the nitrate is coming to the surface. So determining this line is very important. Fortunately, at morning, Patabi was showing about the bioargos, where the few bioargos containing the nitrate sensors, we collected that data and tried to actually put up in the climatology and try to see that versus the ROMS model, which are run at INCOIS, and the Numero model that is running at the IITM. We could see that the red zones where the overestimation is taking place with reference to the nitroc line, and blue regions where the underestimation is taking place. So the models could not able to get exact nitroc line. Therefore, some regions, because of the physical mixing, which is directly coming from the winds or the other processes, they may be giving more nutrients to the surface or may be giving the less nutrients to the surface in certain zones. As a result, they could not able to estimate the exact primary production. To avoid these, actually for the last 1 year, we are trying to develop the new climatologies so that we can able to improve the biogeochemical models and their predictions in the future. So like a nitrate uptake rates or the ammonium uptake rate at the F ratios, the depth of nitroc lines using the lot of data we are actually collating the data collected by the several communities from the India and abroad, and also atmospheric nutrient depositions. Similarly, the pH and PCO2 and DAC, all these climatologies we are developing by this kind of a data which is being available in the region, and try to feed these climatologies into the present models and rerun them, and hopefully they may come close to the what observations are saying about in this region. The other important factor here is that the sensitivity analysis when you do with reference to the climatology, we require at least 32 years of the data in order to say that any significant trends you will have in the primary production, whereas at least 14 years of data are required for the pH. At least for the pH, we have such kind of the data in certain zones, but we don't have, not even the remote sensing data, we have continuous 30 years of the data.
2 minutes,
So,
Doctor.
so therefore, yeah,
2
I'm at
minutes.
the end. So therefore, we need to have the more data really to say that how best even our models performs even after changing all these new climatologies, what we are trying to give into that. So I'll try to summarize this. The chlorophyll trends do not really represent the NPP. We need to, when we want to speak about the primary production, better to take the trends from the NPP, not with the chlorophyll since it's available from the satellite. And NPP trends derived for the less than 35 years is not trustable because they cannot give real trends. And the trends in the NPP by different models do not synchronize each other. So we need to improve these primary productivity models. And the numerical models are overestimating the nutrient flux. And therefore, the lack of trends in the oxygen minimum zone, there's a lot of confusion among the regional versus the global models. So we need to fix with more data. And the uniform acidification rate, what we have seen was not actually going with our observations and so on. So therefore, the present projections given by these models, I think we need to be a little cautious than taking very serious unless we improve them. Thank you.
Thank you, Dr. Sharma, for an interesting and important topic lecture. Now, there are 1 or 2 quick questions. We have time for 1 or 2 quick questions.
Very good presentation, Sharma garu. And this actually in this ecological modeling, each term like primary product, nutrients, all these things, the conversions have some coefficients. These coefficients usually we fix as a constant. But mostly in the entire extent of the water, these coefficients, they are not constants. They should be variable. Variable, actually we have to attach with the wind or currents or like that. So most of the variables should be, most of the constants should be variable and connected to the variable. And then if we run the model, ecological model, then we may get the good results. I feel like that.
No, that is why I showed you one of the trends. Actually, these rates have been determined by different people in different regions.
Yes.
We collated all this together. Well, now we made a climatology of the trends or rates in different regions of the Indian Ocean. So that is what we are trying to input into the model now, so that we will get the better outcome.
Yes. Actually, the coefficient, usually coefficients make this problem.
No, coefficient is the one problem. Even the climatology is another problem.
Yes, another problem. Right.
So these two need to be improved.
You are right.
Yeah.
Okay, thank you. Thank you very much.
Thank you.
Thank you, Dr. Sharma. If there are any questions, okay. Thank you, Dr. Sharma.
Excuse, I think this is like a very general question, but I just wanted to ask, sir, why are the models predicting different levels? So in one model, you showed that the nitrate in some parts were higher than the rest. Why are they giving such like various kinds of results?
Because each model, what they are setting, they are using the different kind of the coefficients and the different kinds of the inputs they are giving into the system. So that is giving the outcomes are also different. Okay. So the initial conditions are variable for the each model. And like a primary productivity model, when you take, some people are using only light, temperature, chlorophyll is a controlling parameter. Some people take POC to chlorophyll ratio is also controlling parameter. Some people take say another spectral data also they are using to compute the NPP, for example. So because of those coefficients which they are using in them, so it is showing the variability. So finally, it has to match with the data at the end of the day. So that is not happening because the climatology which they are using is also different. Now, some people are using the regional climatologies, which have been developed by themselves, using the data is available. Now, INCOIS has some data, NIO has some data, NCCR has some data. Nobody putting together all this data. Then only you will get a better climatologies. So people are using the different backgrounds, so different coefficients. So that seems to be the major cause for the variability among the different models.
So in your idea, sir, is it better to have more number of variables? Will it make the model better? Or choosing the correct coefficient is the best way to go?
You see, first thing is that the backbone for the any model is actually the climatology, because from that we start mixing the things and slowly either giving the nutrients or removing the nutrients. That's the first fundamental one. The second one is that at what rate you are removing. For example, I will tell you that nitrocline depth is at the 40 meters. You have a mixing that brought 2 micromole of the nutrient to the surface. If you know the exact coefficient, okay, the uptake rate is 0.02 micromole per liter per day. 2 micromolar will work for a few days. How many days you can able to compute, right? So this kind of computations goes into the model. So the coefficient is equally important. The amount of nutrients coming through the mixing is also equally important to sustain the biology.
Okay, thank you, sir. Yeah.
Thank you. Let's give a round of applause to Dr. Sharma. Now I'll call upon Dr. Justice S. Chaudhary, scientist F from IIT Pune, to deliver his talk.
Yeah, thank you, sir. Okay. Good afternoon to all. Let us have some discussion on monsoon. So I'm going to talk about climate teleconnections and Indian summer monsoon variability. So climate teleconnections plays an important role in determining the summer monsoon variability and predictability. So the complex association among cities makes it more challenging to understand the individual contribution and combined influence on the summer monsoon. So we have many climate modes that actually influencing the Indian summer monsoon. And we have more important climate mode is called El Nino Southern Oscillation that has strong impact on the monsoon. And apart from that, we have many other teleconnections or climate modes from the tropical regions as well as the polar regions. So what you see here is the time series of monsoon rainfall. So there is fluctuations from year to year as well as from one decade to another decade. So prediction of these fluctuations is always challenging. So, and most of the predictability on these changes are coming from the remote forcing. So we need to understand how remote forcing is influencing these changes so that the prediction can be improved. You know, IMD issues a statistical forecast based on various regional patterns, for example, SST pattern from North Atlantic and Pacific Ocean, and pressure anomalies from East Asia, etc. So this collection of predictors clearly indicates the importance of remote forcings. And we have dynamical models these days. And these dynamical models are doing pretty well, but still we are not yet there to accurately predict the monsoon variability. And the variability or prediction is basically coming from this remote forcing. And you can see this diagram. Monsoon is influenced by various climate modes. And so itself has many flavors. And then we have Atlantic, and we have a PJ pattern, and many other climate modes on the interannual time scale and interdecadal time scale, and even on the climate change point of view. So if we thought of having a particular volume if we can discuss all these modes impact onto the summer monsoon. That would be useful for at least the early career scientists as well as the students. So then we came up with this publication recently. So this is about Indian summer monsoon variability, El Nino, teleconnections and beyond. So edited by myself, Dr. Anand Parikh and Dr. C. Gnanashilan. So this book actually synthesizes all the aspects of teleconnections. So these are all various chapters covered by various, contributed by various experts in this field. So I may not be able to cover all those teleconnections, but let us discuss some of those now. And this particular figure D shows the negative rainfall anomalies associated with El Nino. That means when you have El Nino, you do have kind of 50% chances that you have a deficient monsoon. And even non-El Nino years also we experience kind of low rainfall. During non-El Nino years, other climate modes are always important. When you have El Nino, obviously the water circulation from Pacific is altering the monsoon. And then these monsoon teleconnections with time are not really stable. You can see that weakening in the recent period. When we consider area average over India, what you see is there is a weakening. But it is not true spatially. If you see spatially, north and southern part are having a strong teleconnections even in the recent period, but central part is weakening. So models somehow they don't have a great skill in capturing that spatial variability. For example, in the observations we have gradients, but that gradients are missing. Either they're overestimating or they are underestimating. So we have problems. And what we are talking about is the canonical El Nino, but we have other flavors of El Nino, kind of modicky. So what you see in the first two panels, like this is a canonical El Nino, that warming from east to like extending to central Pacific, and then this is a La Nina. But we have another type of El Nino called El Nino Mudaki or Central Pacific El Nino. So it warming or cooling is over this particular Central Pacific region. How it is influencing the monsoon rainfall? When you have a kind of strong warming in the Central Pacific, so we have a heat source there. So associated with that, you do have a cyclonic circulation as a part of Mestuno Gulf, and then that is extending to the monsoon region, and we have a kind of high rainfall in the monsoon trough region, but it is inversely correlated with the southern parts of India. So Modiki have a different type of impact than canonical El Nino. So, and what we know is mostly when El Nino is developing, it's going to impact the monsoon. But it's not that only developing phase. When El Nino is decaying, for example, this year, El Nino is decaying. That means we are translating from El Nino to La Nina. So what we see in the pink curve, it shows the autocorrelation of Nino with Nino 3.4. So El Nino is peaking in DJF and then decaying by summer. And Indian Ocean warming is following with a lag of 2 months and persisting even after El Nino goes off. Let us see in detail here. We have El Nino peaked in DJF season in winter, and then by JJS it is gone. And then when you have El Nino, there are a lot of changes in the circulation. So it excites the anticyclone over Northwest Pacific that we can see here when you have El Nino. So we have a cyclonic circulation in response to heating that excites the cooling over this region. This cooling again excites anticyclone over this region. And directly the sinking over this region, maritime continent, causes anticyclone. That causes like downwelling Rossby waves. That causes warming. That actually helps to sustain the warming of Indian Ocean to the next season. And this warming is because of ocean dynamics as well as direct impact of El Nino in March, April, and May. And this anticyclone, you can see that is persisting even MAM. So last spring, we do have this anticyclonic circulation, and these generally atmospheric circulation doesn't persist for 3 months or even 3 seasons. But ocean anomalies can persist, that we can see basin-wide warming of tropical Indian Ocean is persisting till this summer, and this is again maintaining this anticyclonic circulation through Ekman divergence mechanism. So when you have strong warming over this region, we have a strong convection that can produce strong tropospheric warming that can propagate as a Kelvin wave to the Western Pacific. That Kelvin wave maintains this anticyclone, and this anticyclone again feeding back to the basin-wide warming, because due to this anticyclone, easterlies are seen against the southwesterlies. That means southwesterlies are weakened. That means the latent heat flux released to the atmosphere is less. Therefore, we have a strong warming over this region. So there is an interbasin interaction, and this interbasin interaction is playing very important role in modulating the summer monsoon rainfall. So we can have a schematic diagram here saying that what we call this interbasin interaction is the Indo-Western Pacific capacitor. How we can say it is a capacitor effect? For example, El Nino is like a very huge battery, and it recharges or charges or changes the atmospheric circulation. So we can consider it as a battery, and then when you have El Nino, basin-wide warming is induced by El Nino, and that is what we can say Indian Ocean is charged, and then El Nino is triggering anticyclone. So anticyclone is persisting, even ENSO is gone, and then when ENSO is gone, that means our battery is discharged, and then capacitor starts reacting. So this capacitor actually maintains this anticyclonic circulation, and thus these together, anticyclonic circulation and the basin-wide warming, both acting together and influencing the Indian summer monsoon rainfall. You can see that because of this anticyclone, we have divergence over the eastern parts of Gangetic Plain and low rainfall there, and southern parts we do receive high rainfall, and northeastern parts as well. So how relevant is this research to the real world? So this year, if you see, January 2024, we have El Nino decayed, and it is decaying by August. We have a La Nina-like condition here. And Indian Ocean basin-wide warming is persisting. At the same time, from May onwards, you do see easterlies penetrating to the Indian summer monsoon region, and then they are also persisting till even August. So there is anticyclonic circulation week 1, and there is a basin-wide warming. So this year, the IPOC mode is operative, and it is influencing the Indian summer monsoon. Then how exactly the decaying El Nino related to IPOC? You see, this is a real-time ENSO index, and this year El Nino is gone by July, and it is not that each year, each El Nino is going to decay by July, so it is going to decay in different ways. Like some of them are decaying faster, and some of them are decaying slower. And this year, we have classified the decay into 3 categories. So El Nino can decay before May, what we call as a early decay, and in summer monsoon season that can decay, we call it as a mid decay, and if some years it doesn't even decay, so it becomes again El Nino, so we call it as no decay. So it will have a different impacts, and this year the category comes under the mid decay. And with that, what we have is the JJA rainfall anomalies. You can see low rainfall over the Gangetic Plains, and then high rainfall over the southern parts. So what you see exactly, it is happening in the composites, but the colors are reversed. Here blue is negative, here red is negative. So this year rainfall, especially 2024, is highly influenced by the Indo-Western Pacific capacitor effect during the decaying El Nino. So how it is operating? We have anticyclonic circulation over the Northwest Pacific, and we have cyclonic circulation north of it, what we call is a Pacific-Japan pattern. So that interacts with the tropical Indian Ocean, and that enhances the convection over the Indian Ocean and the associated atmospheric Kelvin waves, again propagating to the Western Pacific and maintaining the PJ pattern, and PJ pattern again feeding back to the monsoon. So this is the interbasin interaction is very important, and this is the difference between a decaying as well as developing phase of El Nino circulation patterns. Actually, these circulation patterns determines the rainfall distribution over India associated with El Nino cycle. So El Nino cycle, and we have other modes. We can start with some of them, like Indian Ocean dipole. So when we have strong Indian Ocean dipole, this is a strong case. We do have some impact on the monsoon. When we have weak, then it will have a limited impact. But one of the important point we brought out here, when you have a strong IOD, we do see double Walker circulation, which is unnoticed earlier. And when we have weak IOD, we have one single kind of cell we have seen. So IOD do have strong impact on the Indian oceanic rims. And isolated impact over the northwest, southwest India can also influence the monsoon. When you have convection, over this region, moisture is very high. So associated with southwesterlies can have a moistured wind entering into the India and can cause a impact on rainfall. That southwest Indian Ocean warming is because of the westward and upward propagation of downwelling Rossby waves, and that have strong impact on the cyclones as well. And apart from Indian Ocean and Pacific, we have Atlantic Nino, that too have a strong impact on the monsoon, especially regional patterns. So when we have Atlantic Nino in the model, we have artificially generated Atlantic Nino. It generates a stationary wave by modulating the ITCZ, and it actually strengthens or weakens the westerly jet over that region, and that actually influences the monsoon. Apart from that, even when you have a strong warming over the Atlantic Nino, it can directly influence the monsoon through Kelvin waves. So there are two pathways, one from the mid-latitude, one from the equatorial region. And apart from this tropical oceans, we have mid-latitude kind of this snow, Eurasian snow can influence, but the teleconnections with snow is decreasing in the recent years because of changes in land use, land cover, and land and atmosphere interactions. So we need to take into account all these teleconnections. So one of the important aspect is the PJ pattern. So Pacific Japan pattern is highly influencing the Indian summer monsoon in both subseasonal as well as seasonal point of view. So this is the stationary mode with high, low, and high along the western North Pacific. So it is influencing the monsoon by emanating the cold Rossby waves in the trough region and warm Rossby waves through the to the southern parts of India. So this is another mode that is not taken into the account, that needs to be taken into the account when predicting the monsoon. And that mode is also highly interacting with the mid-latitudes. So mid-latitudes jet, when it is moved southward, obviously we have kind of equivalent barotropic structure that enhances the anticyclone. Again, it interacts with the monsoon, and we have a mid-latitude interaction through PJ pattern to the monsoon season. And we have another mode, dominant mode over the mid-latitude is called the SRP, Silk Road pattern. So this is kind of wavy pattern, highs and lows. When it moves south and north, it will have a strong impact as well. So in you can see some of these cases. August, the jet is moved southward, we have low rainfall. Jet is moved northward, we have a high rainfall. Even last year, only in August, the waves that are generated due to the El Nino in the mid-latitude propagated to the East Asian region, and that actually reduced the rainfall over Indian summer monsoon region. That means there is a strong interaction between the mid-latitudes as well as the tropics. And then these mid-latitude circulation can influence the South Asian high. When it moves northwestward, it enhances the rainfall, and when it moves southward, it decreases the rainfall. Not only these, and we have a desert. So intensification of deserts or brightening or darkening of deserts can modulate the monsoon. So when there is a darkening, so generally the monsoon propagates much faster. When there is a brightening, there is a nonlinear relationship. So And we have our own study talking about the southern angular mode. So we have moved from northern hemisphere to southern hemisphere. So southern angular mode is a kind of SLP pattern, and that has a lagged relationship with monsoon, and that actually have a strong impact on monsoon by interacting this through the tropical SSTs. And not only that, we have Atlantic multi-decadal oscillation on the decadal point of view is influencing the monsoon through 3 pathways. One is to shift in the intertropical convergence zone and atmospheric teleconnections as well as tropical Bayesian interactions. All these mechanisms can cause changes in rainfall on the decadal time scale. And PDO or IPO from the Pacific also have a strong impact on the monsoon. So we need to take into the account all these teleconnections when we talk about the monsoon.
2 minutes.
Yes. And then in future, teleconnections are increasing or decreasing, it is a question mark. So when you don't remove trend, what you see, the teleconnections are weakening, but when you remove trend, you see they're strengthening. So it is like very non-linear. So we need to understand more about that. And then extreme IODs are increasing in the future, so they may influence the monsoon more in future. And we have aerosols impact. Without oceanic impact, aerosols have a strong impact. It might like weaken the monsoon when we have a lot of aerosols in the atmosphere. So this is to summarize that just we have a lot many teleconnections around, or a lot many climate modes. They are interacting together in the real time, and then we need to understand their interaction. Just an example here, you can see in a single month or August and September, there are various modes present here. You can see a PJ pattern here, you can see a La Nina type, you can see Atlantic Nino here, and SRP here. So there are 4 modes in a single month. So how do we account their impact on the monsoon is a big question. So yeah, thank you.
Thank you, Dr. Chaudhary. We can have 1 or 2 quick questions. Oh. Interesting presentation on a very important topic.
Hello? Yeah. Well, thank you very much. Very nice, very informative. For me, it's a very good talk. And if you allow, please, I have a few more questions, more to learn from you. Okay? First is this. As far as I know from the literature I have been reading recently, the El Nino changes are so high, they're nothing like canonical. You say canonical, only there are very similarities. The dissimilarities are so large, there is nothing similar between one to the other. So there is a big question about canonical El Nino, particularly in the global warming context. For example, if there is a sine wave, there is no mean, it's 0. Okay? So if the standard deviation is very high compared to the mean, mean has no meaning. So I have a big question. Anyway, let me complete, then you can answer, please. Because I want to learn from you, please. So you have an explanation whether canonical El Nino has any meaning, first. Then another question is about the middle latitude and the monsoon interactions. I have a paper recently published in QGRMS where we studied heat waves for India using some sort of a theory developed by Charney and another, I don't remember his second author. That is a sort of resonance. You see, if there is a middle latitude wave coming to the south, and if there is a local wave, there could be a resonance, you see, and that can promote. There are many papers by Kornhuber, many other people. They try to explain in the European region, many other regions, there is a new theory, some sort of a new theory, where there is a resonance between, you said there is an interaction between middle latitudes and the monsoon. I'm going a little ahead, trying to explain through theory that there is some sort of a resonance that will increase this interaction and produce that. And from all your talk, the IOD and then El Nino, even the so-called Atlantic Nino, I was there for 50 years, that Brazil 50 years. So I know thoroughly how it influences. There is Fred Kujaski's papers I read also. There's some sort of a reverse thing. When there is monsoon here, the Rossby waves propagating east to west, that influence northeast Brazil, very similar to that. The wave you are saying in the equatorial region, you did say exactly, over the equatorial region, the so-called...
So coming to the atmospheric moisture, this is a study we have carried out. As we know, the monsoon low pressure systems are the major rain-bearing systems, and we try to, we called climate surrogate experiments. You play with the model and you create a scenario where the moisture will be kind of a elevated one based on our long-term standard deviation over Indian region. And we have considered Arabian Sea system as well as Bay of Bengal system. This is the composite picture. What you are seeing here, this is an elevated moisture scenario, and this is a reduction of moisture scenario. So as for the Clausius-Clapeyron equation, we are seeing there is a warming atmosphere, and at the same time you have rainfall, and which was expected. What is new in this study is this part. What we have found out is the changes what you have been made, which we call as a climate surrogate experiment. The major changes are not noticed in the convective part of the cloud, which we are anticipating, but it didn't happen in that way. What is the major change we have noticed is the kind of a stratiform part of the rain. So stratiform part of the rain is basically contributing to this elevated rainfall scenarios in a climate change scenario. That's what we have concluded. We looked at some of the classification of different clouds. What you are seeing here from the top is the horizontal picture, and if you vertically slice it using the model data, you will get some of these parameters. This is what we call as a control experiment, and this is the elevated moisture scenario, and this is the reduction moisture scenario. What you are finding is these clouds and their heating structure is drastically getting modulated, leading to that stratiform rain as well as more stratiform clouds in the model. This is a latest work we are still investigating. This is a scenario where you are talking about role of sea surface temperature. It is changing the moisture of the storm, and that is impacting your intensification. That is the goal. What you are seeing here is a cross-section of radial cross-section of Amphan super cyclone. And this is a pre-RI phase, this is RI phase, this is supercyclonic phase, and this is the post-supercyclonic phase. What are the experiments? Mostly the first row, you can say you have we have two models we have given. The middle one is the HICOM input has gone. The lower one is the NEMO model, ocean model has gone. And the upper one is basically the controlled one. What we have found is this HICOM have a better result. But what is unique, I want to highlight here, if you see this is the eye wall region, there is a continuous overturning circulation is happening, and it is rising as you are going in time. And when it reaches to the mature phase or post-mature phase, then basically it is creating kind of a balance. It is suppressing the intensity. It is not allowing to go much more explosive intensification, which is erroneous. And that's what we have seen in this model as well as this model. The point is, the sea surface temperature, what you are playing with, ultimately leading to the moisture content and the heating content, and that's what leading to this overturning circulation. We are still investigating it. So this is what we have seen, the temperature. This is the overturning circulation storm, and you can see this is the supercyclonic phase of the Amphan. The heating was completely much lower compared to other storms. This is a rainfall happened in Kerala 2018, and massive damages happened. It also repeated in 1921. We looked into that. So as usual, it's climate change, a lot of moisture is coming into. We have segregated the budget equation, and we have seen the prime terms and the mean terms. So yes, that's an elevated storm moisture surge has happened. But what is new we have found is this one. This is a monsoon depressions which were form over Head Bay and moving to the central India region. And this particular system is basically act as a kind of a supportive system. This is the windward side of the mountain. If you stand in the coast of Kerala and look towards the Gujarat, this is the Western Ghats. So windward side, it was expected. We always expected rain in the windward side. But those situation, leeward side districts are also got huge amount of rain. To answer that question, we looked into the role of the monsoon depressions over the Bay of Bengal. What you have found is these structures are highly distinct, creating some kind of semi-permanent features of cloud, as well as the updraft in the middle atmosphere with a lot of hydrometeors leading to this catastrophic flood event. And this moisture interjection to the system in the Kerala is continuously happening to the upper atmosphere, and it happened in 2018, 19, even 21. And this year, July 31st, the Wayanad incident, there is a monsoon depressions over the Head Bay region. So these are the new dimensions to know the uncertainties which you were not aware of it, and gradually, because of more data and more high resolution simulations are coming into picture. This is a case of land atmospheric interaction. This is the Kedarnath flood 2013. We are all aware of it. This is the classical knowledge what we have about those systems. This upper level cold air, lower level moist and warm air, they meet over the orographic, highly orographic region, and cloud burst happened. The new thing what we have found out is the role of land surface. What we have found out is if you put your land state correct in the model, basically it is creating a channel of soil moisture, warm soil moisture channel, which is supported by the atmosphere and injecting a lot of moisture from Arabian Sea to the event area. And Arabian Sea, multiple have studies that SST is warming. So this channel is facilitating the moisture to pumped into the event to make it highly catastrophic event. So land state also is a essential part of examining the severe weather events over India. This is another aspect, how the continental and chemistry and cyclone will work together to regulate your intensification. This is the cyclone funny, and what you are seeing is what is the best SIRA available analysis. The first one is you don't touch anything in the model, you allow as it integrated. The second one is you add chemistry into it. What we are finding is, if you add chemistry into it, it is sustaining its score for a longer time, and which is closer to the observations. And the reason is, what we have found is, it is precipitating less. If you put chemistry, because the continent, because these are very, very essential, particularly for pre-monsoon systems. Post-monsoon may not react to chemistry that fast or aggressively, but pre-monsoon systems are bound to act to these dry situations which have prevailed over the Indian region. And if you pump this aerosol and chemistry into it, there is a competition among the cloud condensation nuclei for reaching that critical radius. That's why the rainfall is reducing in this area. That's why maintaining the heating structure and allowing further to maintain the structure of it. And we didn't find them in the control run. These are kind of new dimension over the Indian region, particularly the landfalling system. Can we ignore chemistry as we are forecasting, particularly pre-monsoon cyclones? This is a concept, precipitation efficiency. If you make it the story short, it basically tells you how much moisture is given to you, how much you are able to convert it to rain. So these are two systems, cyclone Fani and cyclone Yash. Cyclone Fani is remembered for the wind damage, but if you see Yash, it is remembered for the rainfall. So we want to look into, these both are pre-monsoon, but we looked into the ability of the systems for generating this rainfall, why the Yash is able to produce much more amount of rainfall. So this is what we found it. The precipitation efficiency, particularly for the Yash system, is much higher compared to the Fani system. If you see their intensity, this is extremely severe cyclone. This is also a very severe cyclone. If you put a threshold, maybe 30, 40 knots difference. But they have a huge difference in the rainfall estimation. So the bottom line is, particularly for the pre-monsoon system, another thing I found is this Yash system is very close to the monsoon onset. It is sometime around May late, whereas the Fani was early May. So the monsoon moisture also gone into the system compared to this Fani, leading to immense amount of rainfall. This is a ARC interaction. What we have done is we used a regional couple model to look into the monsoon depressions and how they respond if you put ocean into it. Particularly the challenge is very high for the system because these are disorganized system. Cyclone is a highly organized system. So we looked into it, and what we have found is the couple model is improving the skill, but the challenge is we have taken these 4 monsoon depressions. The bottom line is, if the system is spending some more time over the ocean, then you are making some sense of using couple model. If you are using couple model, the systems which are close to the coast and getting into, then the land surface is basically a dominant factor. But particularly for little bit longer time, if some system is spending over the central bay or the northwest bay and then entering into the land, you get a very good response in the terms of skill, rainfall, as well as wind. This is another study what we looked into land-based systems. Now 2024 also major systems are land-based. So this is a system which happened in 2022 that Professor Krishnan was saying. Gujarat, it has impacted Gujarat a lot. We are not worried about rainfall. We looked into rainfall. I'm not going to discuss here. But what we looked into, we checked into 3 components: dynamical contribution, thermodynamical contribution, and AD contributions. So what we have noted is during the initial hours of the system which is maturing over the land, the dynamical contribution is very, very dominant. But then as the system is maturing and progressing, the thermodynamics takes over. Thermodynamic takes over. Even later part of the system, your AD is also contribute. That is also maybe part of the model limitations as you are going to day 4. Then this is what I have added. When you club the dynamical model with AI model, you are basically getting a quantum jump in the prediction skills. Ultimately, the goal of our, particularly my group, is to look into how good we are predicting rainfall. And we took two areas. One is the terrain, that is Assam, which is a mountainous region. Our skills are extremely poor, particularly over the mountainous region. And then we have also considered state of Orissa. So what we have noticed is we took this WRF model, we run all the combinations, we create ensemble of combinations, and we plug that into the AI model. Here it is the UNET model. And what you are seeing is this is the best ensemble of this WRF is producing for a particular district, Kamrup. And this is the ML model, what you are creating without residual and with residual. This is what IMD observation. This is unbelievable kind of jump we are getting. Overall skill just jumps from 38% to 76% up to day 4. And we have all categories of rainfall, light rainfall, moderate rainfall, heavy rainfall. And we do find that particularly these heavy rainfalls are particularly 100 millimeter per day. Those category of rainfall is kind of a just a unbelievable. And this is the way we have to go forward, because this kind of skill, I personally feel, by improving land surface parameterization, data assimilation, whatever you may not get it, this is just happening now, and I think it's a big way forward. This is also we have done for monsoon depressions. That was case for the Assam, was the monsoon particular case of 2023. We tried to look into the monsoon depressions and low pressure system which occur over the Orissa. These are depression cases, these are the deep depression cases. And we looked into these plots, district scale, and this is another model we have used based on the spatial attention based AML model. And again, the skills are unbeatable and in all category of rainfall. This also we tried, because these are done on the retrospective cases. I tried for the real time, taking the GFS real time data and predicting it, and that also came out very nicely using this ML model. So these are the kind of major kind of achievements out of this model and the prediction improvement. And finally, if I look into what is the way forward, then we will keep on working for a long time on this process study, data, observation, mechanism, ensemble modeling, regional couple model. This is an inherent part of the goal. We'll keep on doing that. But this particular entity is coming in a big way. It is going to change the way we work and the way we forecast. It's going everywhere, data assimilation, parameterization, prediction. So this is unavoidable. The sooner we adapt, it is better for us. At the same time, we will keep on working on whatever our traditional understanding, improving our understanding. So thank you very much for giving this opportunity, and I look forward if you have any questions.
Thank you, sir. We can have one quick question, sir.
Actually, hello, Sandeep?
Yeah, sir.
Yeah, it's not a question, it's a comment. The precipitation efficiency, what you are talking about, the ratio between precipitation and the water vapor content, it is as old as a book in Sellers, W.D. Sellers, 58 or 55 something. He calculated for the United States, and we calculated, that is about almost 20 years back, for northeast Brazil, for 2 years of drought and what you call flood year. So that precipitation efficiency calculation is already known very well. Okay, just a comment. There, the problem is precipitation can vary, but moisture content you have to take the day average. That is not very, very much. So it's already defined in long back by Peter Sellers, the W.D. Sellers has calculated in his physical climatology book. That's all. Thank you.
Yeah. So to answer that question, sir, actually what you looked at, these models are run at 1 kilometer, 1.5 kilometers. So this hydrometeor concept is recently been built. You have ice, snow, grapple, and all this phase of this rainfall is attributing to that cold phase of the storm. There is a warm phase of the storm, there is a cold phase of the storm. So these additional value addition because of cloud microphysics. So one is large scale conversion, another is this fine scale conversion because of hydrometeor, because of high resolution models. So that's what I tried to show it. And second aspect is the storm which is close to the monsoon onset or away from the monsoon onset. That also drives how much moisture is pumped into the system, and that is ultimately reflecting even the category of the storm also important, but how much moisture you are pumping it, how hydrometeors are working together to convert that to a rainfall, is that what we have discussed. Yeah. Okay.
Thank you very much, sir, for an interesting lecture. Let's give a big applause to Dr. Sandeep.
May I now request this session's speaker, Dr. GVM Gupta, Dr. Kamaljeet Ray. I think Kamalji is not there. She has already left. Dr. VVS Sharma, Dr. Jasti Chowdhury, and Dr. Sandeep Patnaik.
Oh, they are all left, I believe.
May I now request Dr. V.S. Murthy, Chairman, to honor Dr. Sandeep Patnaik. I think, may I now request Dr. Jasti Chowdhury? Yeah. Dr. Jasti Chowdhury. Yeah, kindly receive a memento on behalf of the department, sir. Yeah. అక్కడి నుంచి తీసారా? యా, థ్యాంక్ యూ సార్. Yeah. Yeah, I have still a pleasant task to perform. To honor our chairman and co-chairman, may I now request Dr. V.V. Gopalakrishna to come, sir, once? Yeah, to present a memento to our chair and co-chair. I think we are already running late by. Thank you very much, sir. We are already running late by 30 minutes. We'll break for a tea for 15 minutes, and then we'll be back by 5:30 for the parallel sessions. And you can have tea on the rear side of this hall. May I now request anybody who is claiming travel may kindly fill up the forms and then deposit them at the travel desk, which is being organized at the entrance, right at the entrance. I repeat, anybody, any research scholar or any other delegate claiming travel may fill up the forms and then submit them at the travel desk right in the front of this hall. Thank you very much. So we'll be meeting here within 15 minutes.